So I'm going to show you how to graph this same data using Desmos. So I've opened up a new graph here on Desmos. So this is what it looks like when you just go to desmos.com/calculator. So we're going to click this button right here and then add a table. X, remember, is the independent variable, and that means the one that you are changing. If you're doing a science experiment and fertilizing these plants, you're changing the amount of fertilizer. So that's independent. And then Y, one that goes up and down, is a dependent variable and it depends on the other one. So the amount the plant will grow will depend on the amount of fertilizer you give it. So that's Y dependent and X is independent. And X and the independent variable should always be first in the table and should always go along the horizontal left and right axis. So I'm going to start typing in numbers. So we have 12, 98, 8, 79, 6, 59, and so on. This is a little bit faster, straight down the column instead. Okay, so there's the table. So now I don't need that other window anymore. So now we can see it on the graph. It's only showing up to 6 and down to -6 on the y-axis and between 10 and -10 on the x-axis. And absolutely none of these points are on there. Now remember, each of these values, the x and the y, correspond to a point that we could write like, let's see if it'll let me. Here, I could write, no, I can't. So these, for example, the ones at the bottom correspond to this point, 2, 21. So if I had 2, 2, it would look like this. There's the little blue. If I change that to a 5, you go over 2 to the left and then up 5. But really, this is 2, 21 and off the screen. So what we're going to do is move the screen around. So you can take your mouse and drag it around. And maybe, oh, look at that. We can see some points. But I can only see 2 of these points. So there's 2 ways to do this with Desmos. If you have a touchscreen, you can click or use 2 fingers and hold it on the axis and squeeze it either together to zoom it, to make it bigger, or you can do this one this way. The other way, if you don't have a touch screen, you're going to go up here to this little wrench. This is settings, and we're going to go to the x-axis and y-axis, and we're going to change the scale. Now, if we have a plant, we can't have it below 0 centimeters tall because that doesn't make any sense. So our y-axis, I don't really care with these negative ones. So I'm going to put 0 at the bottom here. So now all the way down here, right at the bottom, it's at 0. Now with this one, I'm just going to go slightly below so that I can still see that line. Same with the x-axis. I can't have a negative amount of fertilizer, so I'm going to put -1 so it pushes this over to the side. If I put 0, that will work too, but I just can't really see very well on her. So I'm going to go like this. Then we're going to look at what are the values over here. Our biggest x value is 12, so we want to go to at least 12. We can go just to 12, and that will put 12 right over here in this corner, which means that our biggest value is going to be over here somewhere. But look, I can't even see it because it's at 98. So I still need to adjust my y value. And remember, this symbol means less than or equal to. So -1 is less than x, which is less than 12, which means we're showing all the x values between -1 and 12. The y values right now are showing between -1 and 87.518. That's not high enough. Our biggest number here is 98. So if I go up to 98, what that's is it put this 12 and this 98 right up here in the very top corner is that biggest point we had at 1298. But like I said, we can't really see that. So in math, it's absolutely absolutely okay to go a little higher. So I'm going to, oops, not that one. I'm going to go to maybe 15 here and maybe 100 and something here, maybe 110. Now if I get out of here, now I can see every single one of those. And now it's easier to move around if needed. And I can zoom in and out either on the whole graph or like I said, you can grab one of the axes and make it bigger or smaller. So I'm going to readjust so we only see what we need. And there we go. So there's the graph. And just like the graph that they came up with in the video, it looks pretty straight along here, but then it kind of curves off at the end here. So I'm going to show you on Desmos how to type something in so that it will show you a curve or a straight line. So we'll start with a straight line. I haven't taught you guys this part of the linear stuff yet, but eventually you're going to get used to seeing this equation right here. However, if you want Desmos to graph it, instead of that little equal sign, you're going to put that little symbol. And then the other thing that Desmos needs is x1 here and y1 with a little 1 at the bottom. It's called a subscript. If you don't have it in here, you're going to get this error and it doesn't understand what you're trying to do. So you have to put a 1 and a 1. Or if this graph, if this table said x2 like this and y2, then you would put a little 2 beside these. So what it's done now with y1, that little squiggly line, mx1 plus b, is it's made this red line on the graph. Eventually we'll talk about other curves. We could also make it kind of curvy like he did in the other video, but for now we're just going to stick with the straight line, and this is what the graph would look like. Just some other Desmos things. If you want to change the color of these points, you can click on here and hold it and then choose. So maybe I want them to be green. Maybe I want them to be open circles or X's instead of points, instead of dots. Now, if we wanted a line graph, we could do this. We do not want a line graph. That is not what we're going for here. This drag thing gives you the option to move the points around, but we don't want that. So we're going to leave that off. And then same thing here. If I want to change the color or the style, I can change it here. Maybe I want it to be green as well. Maybe I want it dotted or dashed or solid. I'm just going to leave it solid. Now what we can do with this is we can interpolate or extrapolate from this data. So interpolate means we're making an estimate based on the data that we know. So anywhere between here and down here, if you're looking at my mouse, what I'm kind of circling with my mouse, anything in here would be interpolation because it's inside, interpolate inside, it's inside the data that we have. So maybe we wanted to know if we gave the plant 10 grams of fertilizer, how tall would it grow? So we could go up here from 10, because remember this is fertilizer, go up here and then over here, and that would be, it's halfway between 80 and 100, so that would be 90, I think it was centimeters, if I remember. Yes, it was centimeters tall. The other thing I can show you is that if you would like to label your axes, the x-axis was fertilizer in grams, and the y-axis was plant growth, I think, in centimeters. Let me just double check. Yeah, plant growth in centimeters. So if you put those in here where it said label, it will label your axis like this and like this. And then the title of your graph would just go up here. You can type in whatever you want. I just called it plant growth video data so I can remember what it is later. And then you can save it. You can only save it if you're signed in. You'll notice I'm already signed in here with my OCDSB account. You can hit sign in with Google and it will save all your stuff. And everything that you save will show up over here. So this is a whole bunch of graphs and things that I've saved before. Okay, so that's interpolation, so within the data. So we could say 10 grams of fertilizer will make a plant grow about 90 centimeters tall. Or we could say, let's say we had a plant that was 40 centimeters tall. How much fertilizer did it likely get? And so we had two that were pretty close. We had a 39 and we had a 42 And both of those got 4 grams of fertilizer. So that seems like a good estimate. It's also right on this line here, the green line. So I went over from 40 to the line and then straight down 4 grams. Or maybe I want to estimate, let's say we had 10 centimeters of plant. It grew 10 centimeters. So that would be right here, halfway between 0 and 20. Go over from here, and it's right about here. So that would be, well, let's see. 4 of these boxes takes us to 2, which means that halfway right here would be 1 gram, and half of that would be 0.5, half a gram. And this is even less than that. So maybe it's about 0.4 grams. Now, if you click on it, you can drag a point all along this line and get a better estimate. So I'll try to get as close to 10 as I can. So there's 10.045, and it is just below 0.4 grams. And if we want to go back up to this one where we had 10 centimeters, it's very close. There we go, 89.957, so about 90 centimeters. Now, the one that I did over here, it's outside the data that we know, which means that we're extrapolating extra, meaning outside something. So if it's within this range, you're interpolating. It's an estimate based on what you know here. And if it's outside, either on this side or up here, you're extrapolating. So maybe we want to estimate if we gave it 20 grams of fertilizer. That's way outside the data. Probably not a very good guess, because who knows what's going to happen since it kind of leveled off here. But if we assume that it's linear, which means it makes this nice straight line, 20 grams of fertilizer, go up here and then look over here, and that's about 170. It's a little higher. 173 might be a good estimate. Let's see. 20, yeah, 173. 172.853, so 173 centimeters of growth. So that's how you make a scatter plot on Desmos. So you make your table, and you can use this to get your line of best fit. Then you don't have to try to graph it by hand, especially since we're doing this stuff online. The other way you can graph all of this is to put each one in separately like this. But that's going to take a lot more time, a lot more brackets, and then if you put them in separately over and over and over, you won't be able to do this thing to get the line of best fit. So it's best if you make a table like this. X is the one that goes on the horizontal axis, the flat one left and right, and it's the independent variable. Y is the dependent variable, up and down the vertical axis. It depends on this one. So if we were to switch the fertilizer and the plant growth, we would be saying that the amount of fertilizer that we give the plant depends on how tall it grows, and that really doesn't make any sense.